Okay, we are going to now start looking at solving exponential equations and inequalities. Okay, so pretty much now that we know how to graph these things, right, and we kind of know how they behave, we can use kind of things we know and principles we understand, kind of from working with exponents and square roots and things like that, to solve these things, and then eventually to do. I mean, the whole point of doing these is to be able to do like more like higher level application problems, right? Otherwise, it's not just to do these like fancy looking things, right? There's a point to this. Okay, so we are going to start by looking at just solving basic exponential equations, all right? So an exponential equation, think about how we write it, right? We have y equals b to the x, right? That's what we always have. We always have something that's y equals b to the x power, right? And so what this property of equality for exponential functions says, right, is that if b is greater than 0, right, and it's not equal to 1, then basically if you have two things that have the same base, regardless of what's going on with either exponent, those are equal to each other, like whether they have variables or whatever is going on. And so like in this example here, and it's kind of a Captain Obvious example, and the way they write it is quite honestly not the smartest, right? But it says, if 3 to the x equals 3 to the 5th power, then x must equal 5. Well, yeah, of course, right? Because x, they have to be equal to each other. And we know they have to be equal to each other because there's this thing called an equal sign between them, right? So it's got to be balanced. So in order for that to happen, whatever's over here has to equal whatever's over here. Now, that's all well and good, right? But we're going to look at some examples now where it's not always quite so obvious how that works, all right? So if we look at this first example here, it says solve each equation. We got two examples, one a little uglier than the other. So you'll notice in this one, right, this first one, we have 2 to the x equals 8 to the 3rd power. All right, now you could do this a couple different ways, and I'm going to show you what I consider to be the smart way to do this, okay? Now, the big thing is the whole way these things make sense and save you any time is only if you always do one thing first, and that's get the same base, right? You want to get the same base. So if my base is 2 here, I want to get a 2 here. And sometimes in order to get the same base, you have to like do some kind of screwing around and that. But in this case, I know that I can't get any smaller than 2. I could get larger. I could move this up to 8. But it would be easier to make this down to 2 because I know that if I just look at 8, 8 is 2 to the 3rd power. Okay? So if that's the case, then that means that 8 to the 3rd power is the same thing as 2 to the 3rd power to the 3rd power, right? Which is, if you understand your exponent properties, is this, right? But what we know what we do with that, right, when you have something and you raise it like that, what are you doing? You're multiplying, right? Multiply those numbers together. Okay, so in other words, 2 to the x instead is equal to 2 to the 3rd power, which is 2 to the x is equal to 2 to the 9th power. All right, and then so if now that our bases are the same, you just take this side and set it equal to this side. All right, so you go x equals 9, and then if you got to do something, you do it, and if you don't have to, then you're done. And in this case, it's pretty much done. X equals 9. And then all you'd have to do to check that is just put 8 to the 3rd power in a calculator, okay? And I'm going to do that really quick just so you believe me. So if I go 8 times 8 times 8, that gives me 512. And then if you do 2 to the 9th power in the same calculator, right? It'll let me here. Let me see, I got to get past my lock screen because using the good old iPhone, we all know how that goes with the calculator. So if I go 2 and then I raise it to the 9th power, that also gives me 512. So it worked, okay? Now this next one right here, we got 9 to the 2x minus 1 equals 3 to the 6x. So you ask yourself, okay, is it easier to turn 3 into 9 or is it easier to turn 9 into 3? Well, it's probably easier to turn 9 into 3. So I know that I can write 9 as 3 squared. Okay, so I'm going to replace 9 with 3 squared on the left side. I'm going to go 3 squared, and then we're raising that to the 2x minus 1 power equals 3 to the 6x. And so basically, seeing as I know that I multiply this and this, power of power, that's how that works, this is going to be equal to this. So this product is going to be equal to that. So we just rewrite this as 2 times 2x minus 1 is equal to 6x. And then you just do your solving razzle-dazzle and see what you get. So we're going to use our distributive property. Get 4x minus 2 equals 6x. We're going to subtract 4x from both sides. To get 2x is equal to negative 2, you divide both sides by 2. And you will get x is equal to negative 1. Let's see if it works. So 2 times negative 1 minus 1, well, negative 2 minus 1 equals negative 3. All right, so we have 9 to the negative third power, which is the same as 1 over 9 to the third. All right, and then if you have 3 to the 6x power, and x, so it's 3 to the 6 times negative 1. Right, so 3 to the negative 6 is the same as 1 over 3/6. And 9 to the third power and 3 to the 6 are equivalent expressions of each other. Okay, they're the same thing. So it works, right? And so this is a tried and true method. So basically get your bases the same. And then once you have your bases the same, you set your exponents equal to each other. And then you're good to go. All right. So I'm gonna pause the video here, and we're going to pick up with a couple examples.